Next, I want to talk a little bit about the connections and the cells that make up the cerebellum. So first of all, we've already said that the cerebellum has a cortex. So on this diagram, we are going to say that this is going to represent the gray matter, and this will be superficial. Then down here, this will be the white matter, and this will be the deeper aspect of the cerebellum. And when we do that, the first thing I want to do is I want to take the gray matter and I want to divide it into 3 layers. And each of these 3 layers is going to be made up of very specific cells. So first of all, I want to just identify these cells. The most superficial layer of the cerebellum is the molecular layer. And the molecular layer is going to be made up of 2 different cell populations. It's going to be made up of stellate cells and basket cells. The stellate cells are going to look like stars underneath the microscope. The basket cells are going to look like a basket. They're going to have a cell body, and all of their processes are going to come out of the top. There are multiple layers of these 2 cells in the molecular layer. Then we have the Purkinje layer. The Purkinje layer is made up of a single layer of very, very large cells called Purkinje cells. The Purkinje cells get their name from the person who first described them. Believe it or not, you have seen Purkinje cells because this is the cell that I used way back when we did the laboratory on neurohistology. It was slide number 3. And I use that because these cells are very, very large. And then finally, we have the granular layer. The granular layer is going to be made up of 2 cells. First of all, granular cells. And the granular cells get their name because of their cytoplasm. They have a lot of Nissl bodies in their cytoplasm that gives them a granular appearance. And we have the Golgi cells. And Golgi cells get their name from the way that they take on the stain and the fact that they were first described by Golgi. So 5 different cells are going to be located within the gray matter of the cerebellum. Now I want to take a moment and look at the connections of these cells. So, stellate cells. Well, stellate cells are going to be inhibitory neurons on Purkinje cells. Basket cells are going to be inhibitory neurons on Purkinje cells. So both stellate cells and basket cells are going to project to the Purkinje cells, and both of these cells are going to be inhibitory on the Purkinje cells. Purkinje cells are going to be inhibitory neurons on, first of all, the deep cerebellar nuclei. And you'll remember that the deep cerebellar nuclei were found in the white matter of the cerebellum. They are also going to be inhibitory on the vestibular nuclei. Just a moment of sidebar, and that is I've placed the vestibular nuclei on this diagram where it's located. But we want to remember or say that the vestibular nuclei are not found in the cerebellum. I've just placed them into this schematic because there was a space to put them. I am not implying that the vestibular nuclei are found in the cerebellum. But the Purkinje cells are going to be inhibitory neurons on the deep cerebellar nuclei and the vestibular nuclei. Golgi cells. Golgi cells are going to be inhibitory on granular cells. So these axons are going to stay in that granular layer. They are not going to leave, and they are going to be inhibitory neurons. So up to this point, what we see is all of the cells, stellate cells, basket cells, Purkinje cells, and Golgi cells, have been inhibitory neurons. Well, granular cells are the exception to the rule. In that, granular cells are going to be excitatory neurons to Purkinje cells. They are going to be excitatory neurons to stellate cells. They are going to be excitatory neurons to basket cells. And finally, they are going to be excitatory neurons to Golgi cells. So when we look at the way that the cerebellum works, first of all, notice this negative feedback loop that is set up between granular cells and Golgi cells. In other words, once a granular cell is stimulated, it can almost immediately be shut back down by a Golgi cell. And that's going to give us a lot of motor control. Notice also that the granular cells can be excitatory to any of the other cells, stellate cells, basket cells, and Purkinje cells. And so the way that this works, and again, I'm making a long story very short, is that if I can stimulate a stellate cell, that stimulation is going to have an inhibitory effect on this Purkinje cell. The Purkinje cell is naturally inhibiting, let's say, the deep cerebellar nuclei. So what I do is I inhibit the inhibitor. In other words, I now allow the deep cerebellar nuclei to do their job. So the cerebellum is really a very, very complex system. But, when you look at it, it boils down to the inhibition of cells that are inhibiting function of different areas of the central nervous system. Well, the next thing then that I want to do on this diagram is ask the question, what about input? Okay, the cerebellum does not work in a vacuum. So we are going to have two different fibers that are going to be coming up through the white matter. The first of these are called mossy fibers. Mossy fibers come from a wide variety of different sources. They are going to come from the reticular formation. They are going to come from the pontine nuclei. They are going to come through cranial nerve 8. They are going to come through the vestibular nuclei. And they are going to come from the trigeminal nuclei. So let's ask questions as to what's going on with all of this input. Well, we know that the reticular formation is also a motor system controller. Therefore, the cerebellum needs to know what other areas of motor system control are doing at any given time. Pontine nuclei. We've seen that the pons has all of these motor tracts running through it. And so therefore, we want to know what the activity level of those tracts are going. Cranial nerve 8 and the vestibular nuclei, those are going to be for balance. So, what is our current balanced state? Are we swaying? Are we, bent over? Things like that. And finally, the trigeminal nuclei. The trigeminal nuclei are going to tell the cerebellum where the head is at any given moment. Because the general rule of thumb is that wherever the head goes, the body is going to follow. Notice that mossy fibers are going to be excitatory on the deep cerebellar nuclei. Mossy fibers are going to be excitatory on Golgi cells. They are going to be excitatory on Purkinje cells. They are going to be excitatory on stellate cells and basket cells. Notice the one that is missing, and that is mossy fibers do not have anything to do with granular cells. The other white matter, fiber is going to be the climbing fiber. The climbing fiber comes from only one area, and that is the olive or the olivary complex, which is also a motor system controller. Notice that these fibers are going to come into deep cerebellar nuclei. They are going to be excitatory. They are going to be excitatory on the Golgi cell. And the real big connection is that these are going to be excitatory on granular cells. So as you are working with this, as you are studying this, make sure, first of all, that you know the different layers of the gray matter. Make sure that you know what cells are in the gray matter. And then finally, make sure that you know what the connection of these cells are. For example, the basket cell is an inhibitory neuron on Purkinje cells. You will not be asked as to how the cerebellum works with all of these different cells and the way that they are connected and the way that they synapse. Okay, that's way beyond the scope of what we need to talk about in this course.